than equal or equal to 1 is false because n is 2 at this point. That means I have to go to line 6 again. I have to do pretty much the same thing as last time. So let me split the screen so we can see just the current context a little bit better. On line 6, we are doing the same thing. We are invoking factorial again. Whatever it returns, I have to multiply that by n and then return the result, which is the product. So I have to set up return info again. I have to set up parameter n again. This time, what do we specify in column I?
1.
1. Very good. Because the current n is 2, 2 minus 1 is 1, and that's why the new parameter n has a value of 1. What do I use to specify return info? Exactly that. Okay, are we doing okay so far? We are specifying the same return info because we are on line 6. When we are on line 6 and we are invoking factorial, then the invocation itself is replaced by a single placeholder, so I can use this placeholder to specify the return value. Once I have the return value, I can go ahead and perform the multiplication, and after the multiplication, I can return the actual value. Can we continue at this point? Is that okay? Okay, let's go ahead and continue because we are not going to call factorial again this time because on line 3, n is less than or equal to 1 is going to be true because n equals to 1 at this point. That means we go to line 4 instead of line 6. Line 4 returns 1. What do we do when we execute a return statement? Exactly. Do we care what is already in the return info cell other than the question mark? No. Okay, so remember that. Okay, we don't care what else is inside the return info cell. I only care about where is the question mark and what I'm going to replace it with. Now you got to remember that part because it will get confusing if you do not ignore the rest of this cell. Since we're returning 1, we are just changing the question mark to 1. I do not execute return n times 1 at this point. I'm just resolving what the question mark is supposed to be. After line 4, we get out of the conditional statement. We end up on line 8, which is the end of the entire subroutine. Line 8 being the end of the entire subroutine will deallocate column H and column I. Then what do we do? At the end of the execution of a subroutine, we rely on return info in this case to tell us where to go back to. Line return info tells us that we have to go back to line 6. So the next line will now be line 6. And this is where things get really confusing, because now we are on line 6. And line 6 looks like this at this point. In other words, we already know what we are supposed to return. We're supposed to return n times 1. The big question is, which n am I talking about?
True cases.
Which column?
G.
Column G, very good. Because when we execute line 6 at this point, column H and column I are already deallocated. So when we specify return n times 1, the n refers to column G, which has a value of 2. So we are returning 2 times 1. What is 2 times 1?
2.
It's just 2. So effectively at this point, we are returning a value of 2. What do we do when we return a value of 2?
Replace the question mark.
We replace the question mark with 2. Now this is where the things can get a little bit confusing. This is what we are supposed to do, but it seems confusing because we are executing line 6, and the effect of executing line 6 is resolving the question mark of a line 6 to 2. Don't let that bother you, okay? If you stay mechanical and just say, okay, we just have to replace the question mark of the return info cell with 2, you would be perfectly fine. The moment you look at the rest of that cell and say, oh, but it is specifying line 6, what am I going to do now? That's why people get into trouble, is because they're overthinking, okay, and not just following the mechanism of this particular return statement. Are we doing okay so far?
So it would be wrong if you just input the number 2.
It would be wrong to replace n times 2 by 2. Okay? Your only job as a return statement is to replace the question mark with the value that you're supposed to return. The rest of that line can be gibberish for all we care. We don't really need to know what is the rest of that line because we are not interpreting the rest of that line yet. Okay? My only job is to resolve the question mark to the value that I'm supposed to return, and I'm done. Okay? So this kind of went back to the question that you were asking a little bit earlier. Remember I asked you to save the question? Does this answer your question? Okay. After line 6, there's nothing else to do in the conditional statement, so we end up on line 8 again. Line 8 will always deallocate the columns for this particular invocation, and then we can go back again. We look at the return info cell, it tells us to go back to line 6, and that's why we are now back to line 6 and execute line 6. Line 6 now looks like return n times 2. Which n am I using for this return n times 2?
E.
We are using column E. Okay? And that's because column G is already gone at this point. It's already deallocated at this point. So we are executing return n times 2, but the n refers to column E, which has a value of 3. So effectively, we are returning 3 times 2. 3 times 2 is 6. We are returning a value of 6. What do we do when we return a value of 6? Replace the question mark. Okay? So I'm kind of hoping that at this time, this is actually becoming somewhat mundane and boring because the return statement doesn't do a whole lot of stuff. All it does is to replace the question mark with the value that you're returning. In this case, it's replacing this question mark with a value of 6, and the return statement is done. We do not print at this point. Okay? It is just resolving the question mark, but we do not execute line 10 at this point. This is line 6. After line 6, we go to line 8 again. Oops, I should not be scrolling this one. On line 8, it is the end of a subroutine. We basically deallocate everything that we allocated earlier. And then where do we go next? We go to line 10, right? And line 10 this time looks like this. Print 6. Oh, we don't have to invoke anything anymore. We just have to say, at this point, we print a value of 6. And that's it. There's nothing to do after line 10. So we go to line 11. Line 11 still has a few things. Well, we still have like 2 things to do. One more thing to do here. On line 11, which is the end of the main subroutine, we have to deallocate column C. And then use column C to tell us to go back to post. But as soon as we get back to post, we are all done because post is an indicator that we are at the end of a trace. Yep.
How did you get 6 again?
Sorry?
How did we get 6?
How do we get this 6 here? It is from executing this statement. Okay, let me just talk about it by pointing because this way it will be captured by the video capture. And let me make sure that it is recording. Okay, very good. Occasionally, I have forgotten to turn on the recorder again, and all the stuff is basically gone. But then again, I also have the Tuesday, Thursday class and the Monday, Wednesday class, so they have the same material as this class, and those are already recorded and published on YouTube. But to answer your question, we execute the statement return n times 2, but in the context of using column E, and that's why we are returning 6. Okay, so we execute line 6 here. When we return 6, we are changing the return info of column D and replace the question mark with a value of 6.
Oh, I see, this chain process.
Yes. So are we kind of doing okay with this? Okay. And how do you guys like this is basically the last reincarnation of the factorial subroutine. This is the cleanest, factorial that we can do with subroutines. If I do it in C, it can be a little bit better, but without using the obscured features of C, this is the best we can do. Are there any questions? No questions? Okay, well, let's go ahead and work on yet another example. So we'll just keep working on examples after examples until we really are familiar with the concepts. So this time I saved this file as factorial but using return values because the other one uses by reference parameters. But before we talk about the next sample program, it kind of helps to look up the definition first. It's called Fibonacci or Fibonacci numbers. And the Fibonacci number, if you look at the definition, it's kind of interesting. It's simple in a way, but it's confusing in a way too. The definition is saying that the Fibonacci number of 0 is 0. The Fibonacci number of 1 is 1, by definition. What about the Fibonacci number of 2? Well, since it does not belong to one of these two cases, you have to use this more general equation. The Fibonacci of 2 equals to the Fibonacci of 2 minus 1, which is 1, plus the Fibonacci number of 2 minus 2, which is 0. Is that okay? No? Okay, n equals 2, so n minus 1 is 1, and n minus 2 is 0. Okay, what about the Fibonacci number of 16? F subscript 16 equals F subscript 15 plus F subscript 14. Okay, so that's how the Fibonacci numbers work. It is a recursive definition, and if you want to do this without recursion, I guarantee your program will be really hairy. Okay, when you have okay, this is a digression, that I should bring up, because some people will have that in your mind. The question is, if I can do something recursively using a subroutine that calls itself, if I can do the same thing without using recursion, using a loop, which way is better? Okay, that's the question. Now, before we answer that question, let me just make a statement first without proving it. The expressive power of recursion, a subroutine that calls itself, is actually equivalent to the expressive power of a loop. What that means is, if you give me an algorithm that has a loop, I can turn that algorithm into a recursive subroutine without using a loop. It also means that if you give me a recursive subroutine, I can turn that recursive subroutine into just a loop without recursion. Okay? So that means these two types of ways of writing code is actually equivalent. They are the same thing. They can express exactly the same logic. But in this case, don't you think this is actually more recursive, or the recursive method is going to fit the problem a little bit better? Just because of the definition of the number of Fibonacci makes this more friendly to a recursive solution. So let's go ahead and see how we can code this in pseudocode, and then we'll trace